share the latest scientific developments happening around us. Please subscribe to this channel and remember to click on the notification bell so that you will be notified every time I release a new video. Also, please give this video a big thumbs up. If you have any questions or concerns, leave some comments below. Many of the new Space Telescope's hours will be devoted to proving some of his theories, which will take years. Another is the very last project Hawking worked on before his death, in which he discussed the multiverse theory, which suggests that an exact copy of yourself existed in a parallel universe. What is the multiverse theory, and will the James Webb Space Telescope finally give Stephen Hawking's multiverse theory the approval? Stephen Hawking passed away in 2018 and missed seeing the James Webb Space Telescope go into orbit in 2021. As a result of a series of delays, the launch date was pushed back from 2007 to 2011. This increased the wait time by more than 3.5 years. It also devoured $10 billion, approximately 10 times the initial budget. However, after a successful launch and development of its components, this powerful space telescope will be subjected to several months of calibration and testing before it begins its operations. The telescope will be able to peer into the atmospheres of planets outside our solar system and peer through massive clouds of dust to witness the birth of new stars and planetary systems, thanks to the sizable 6.5-meter giant mirror that had to be folded during the launch process to gather and reflect light from the early universe, which is thought to be around 13.8 billion years old. JWST will be able to observe light from the very first stars and galaxies that formed shortly after the Big Bang. The JWST is an infrared telescope, which means that it detects objects in space by detecting infrared radiation. It can observe celestial bodies such as stars, nebulae, and planets that are too cool or too faint to observe in visible light, such as the Sun. In other words, everything that can be seen with the naked eye. A study conducted by NASA found that infrared radiation can pass right through gases such as air and dust that appear opaque to the human eye. This is in contrast to the world-famous Hubble Space Telescope, which observes visible light, ultraviolet radiation, near-infrared radiation, and other wavelengths. Shallow temperatures, -370 degrees Fahrenheit or lower, are required to ensure that the instruments on board function properly. The giant sun shield shields the telescope from the sun's heat and helps keep the tools cool. According to a report published in 2018 by an independent review board, there are 344 single-point failures, which were steps that needed to be completed for the mission to be successful. After being tucked inside the nose of an Ariane 5 rocket and successfully launching from the European Space Agency spaceport in French Guiana in December of last year, the telescope was detached from the rocket and began unfolding after launch. According to NASA, the first deployment took place about 30 minutes after the takeoff when the solar panels were spread to allow the telescope to receive power from the sun for the first time. Because of the capabilities of the JWST to compete for time with the telescope, NASA's Space Telescope Science Institute, which oversees science operations on Hubble and JWST, has issued a request for proposals on how astronomers would like to use James Webb. With 6,000 hours of observation time available, the lucky ones have now received approvals for their projects, and we look forward to the wealth of knowledge they will provide us. There is still plenty of time for the James Webb Space Telescope to unlock the deep secrets of the universe, with approximately 20 years of operation guaranteed by the amount of fuel carried aboard the Space Telescope's orbiting laboratory. Now that the JWST has been safely delivered to its location, which is approximately 1 million miles away from Earth, it is time to confirm one of Hawking's most intriguing theories, the concept of a multiverse. In particular, the theory is noteworthy because it was the professor's final published work. In fact, the conclusive research from the brilliant mind was submitted for publication just 10 days before his death. Physicist Stephen Hawking published a paper titled A Smooth Exit from Eternal Inflation, which he co-authored with Thomas Hertog, a physicist at the Catholic University of Leuven in Belgium. He proposed a theory for the universe's origin that he hopes will answer some of the remaining questions. However, even though it was his final piece of work, the paper was a final examination of one of his earliest theories. If the JWST eventually contributes to demonstrating the existence of the multiverse, the scientists who developed it will be strong candidates for the Nobel Prize. However, because Nobel Prizes cannot be awarded posthumously, Hawking would be ineligible to receive it. What is the multiverse theory, and how does it work, and what were the thoughts of the late physicists on the subject? The multiverse theory proposes that our universe, with its hundreds of billions of galaxies and almost innumerable stars spanning tens of billions of light-years, may not be the only one in the universe as currently understood. In a standard universe, there may be an entirely different universe far away from ours, and then another, and another, and another. In fact, according to this mind-bending theory, there may be an infinite number of universes, each with its own set of laws of physics, its collection of stars and galaxies, and perhaps even its intelligent civilizations, all existing simultaneously. In other words, our universe could be one member of a much grander and much larger multitude of universes collectively referred to as the multiverse. However, because the implication of the multiverse is the existence of doppelgangers or copies, it makes us feel a little creepier, according to some. Following the logic, if there is an infinite number of universes, but only a finite number of ways to arrange particles in each respective universe, then the same patterns are destined to be repeated in every universe. After a while, this would imply that at some incredible distance, there would be a replica of you watching an exact replica of this video, and vice versa. Given the fact that there would be an infinite number of universes, there would be an endless number of variations on this theme that would all take place simultaneously. The multiverse concept is introduced in a few areas of physics and philosophy, but it is not widely accepted. On the other hand, the inflation theory provides the most prominent example. It describes a hypothetical event that occurred when our universe was very young, less than a second old, and is defined by inflation theory. In that brief period, the universe went through a period of rapid expansion, ballooning to become many orders of magnitude larger than it had been at its creation. It is estimated that the inflation of our universe came to an end approximately 14 billion years ago. However, because inflation does not end in all areas simultaneously, inflation may continue in some places even after completion. In this way, while inflation ended in our universe, it is possible that inflation continued and continues even today in other, more distant regions. Individual universes can pinch off larger, inflating, expanding universes, creating an infinite sea of eternal inflation filled with numerous separate universes. In this endless inflation scenario, each universe would emerge with its laws of physics, its collection of particles, its arrangement of forces, and its value of fundamental constants all unique to that universe. This could explain why our universe has the characteristics that it does, particularly those that are difficult to explain using fundamental physics, such as dark matter or cosmological constant. According to some scientists, the most compelling evidence for the existence of a multiverse is the existence of intelligent life capable of making cosmological observations in the universe. When viewed in this light, certain aspects of our universe appear to be unique and essential for the survival of life, such as the longevity of stars, the abundance of carbon, the availability of light for photosynthesis, and the stability of complex nuclear structures. On the other hand, all of these characteristics are not typically present in a randomly generated universe. There is an explanation for why all of these characteristics are advantageous in our universe. It is based on the multiverse concept, which holds that other universes exist alongside ours. Even so, we keep an eye on this one because it can support complex life forms. Despite this, according to Hertog, Hawking was dissatisfied with the current state of knowledge about the multiverse, and he invited him to join in an attempt to tame the universe. The pair then set out to devise a method for transforming the concept of a multiverse into a scientific framework that was both coherent and testable. Hawking's final paper proposes a framework for understanding the universe that would make the multiverse finite, countable, and subject to meaningful engagement through scientific tools. As proposed by Hawking, in an exciting twist, Hawking contributed to the theory that led to the concept of infinite parallel universes. Although he admitted that he had never been a fan of the multiverse, he explained that it is a theory of eternal inflation. His comments in an interview are quoted as follows: "The conventional theory of eternal inflation predicts that our universe is like an infinite fractal with a mosaic of different pocket universes separated by an inflating ocean. The local laws of physics and chemistry can differ from one pocket universe to another, forming a multiverse of laws that can be combined to form one larger universe. However, the multiverse has never been a favorite of mine. If the scale of different universes in the multiverse is large or infinite, it is impossible to test the theory of relativity. With the help of string theory, a branch of physics that seeks to reconcile quantum physics with gravity and Einstein's theory of relativity, Hawking and Hertog came up with a new concept of eternal inflation that relies on a boundary at the beginning of time to explain how the universe began. When we trace the evolution of our universe backward in time, the theory suggests that we will eventually arrive at the threshold of eternal inflation, where our familiar notion of time will cease to be meaningful. In the wake of the Big Bang, the new theory predicts a finite structure of universes that will emerge due to that boundary. If this theory is proven correct, it will imply that other universes similar to ours could have appeared at that point in time. According to these new models, there could even be primordial gravitational waves that correspond to the universe's inflation. However, this is still far from proven, and physicists will require more data and a better understanding of string theory before that is possible. In addition, the paper suggests that it may be possible to test this hypothesis. However, sensitive the instruments currently available are, we will not be able to find evidence to support this theory. Scientists, on the other hand, are not discouraged from attempting it. A new generation of tools has been developed to measure ripples in spacetime, also known as primordial gravitational waves. These waves would have been generated by the universe's initial expansion following the Big Bang and could be used to search for evidence of other universes. Another group of scientists has attempted to gather more physical evidence for the existence of multiple universes. A neighboring universe that happened to be close to ours in the past, for example, would have collided with our universe, leaving a visible imprint. This imprint may manifest itself in the form of distortions in the cosmic microwave background. When the universe was 1,000,000 times smaller than it is now, the light in the sky was left over from that time. Leave a comment below and tell us what you think about Hawking's theory of the multiple universes. Thanks for watching Tech Unity.